Hi there, I'm from Metasub Consortium. It's an international consortium. We are running the microbiome sampling, metagenome sampling of major cities in the world with several goals. And I'm going to show a small video about Metasub first. Okay, that concludes the video. I can move back to my presentation. We started with the transportation system. As you can see, we moved to Olympium. We moved to actually some historical sites as well. We are taking samples from those sites. And this project started because of the advancements in the sequencing technologies. And now people are using it for precision medicine, preventive medicine. But we live in an environment, actually we are guests in an environment of metagenomes. And we wanted to take advantage of this technology to map the world, transportation systems we started with, and find out the presence of different metagenomes in different areas. And let's move to the next one. So the goal we initiated with 3 goals: geospatial, metagenomic, and forensic maps of the world, antimicrobial resistance marker tracking. This is a serious threat all around the world. So we would like to overcome this problem. So if we can map the different regions and how it transferred from one organism to another organism, we can find ways to prevent this from happening. So this is the most serious threat that the World Health Organization identified, because antibiotics are not working in most of the cases in many countries. And we can find new biosynthetic gene clusters, new drugs new peptides, antimicrobial peptides, or other peptides that can be used for health benefits. These were the initial 3 goals we started with. And as you saw, we collected samples from everywhere. This is actual collection from Lake Hillier in Australia to identify novel organisms. There are several organisms living in these extreme conditions, and we can learn a lot from them to use for advancements. And we have some projects in Antarctica. We collected samples living in extreme cold environments, how they can survive, and what's the mechanism of their survival. We can learn from them and to use in our advantage later on. And these are actual some pictures of sample collections from the subway systems, Metasub activities. There was a publication, Metropolom, from the New York sampling. And actually, people are afraid what we are exposed to in the subway systems, when you are touching those handrails and other places, what kind of things you're exposed to. So we wanted to map and identify these risks and how we can prevent them. Maybe in certain environment, if you use certain material, then these transfer of microbes or metagenome or microorganisms maybe lessons in that way. So this is part of the research as well, with a direct application and direct effect on the citizens' health. So we are carrying out such research as well, sampling different environments, different locations in the transportation system, and checking which kind of environments, materials are facilitating for these transfer of these microorganisms from one individual to another individual. And this is what we do. We do the swabbing in 3 minutes, and then we enter everyone all around the world. We have a common system. We enter the data after sequencing, and then we upload and establish a GPS tag and time step as a result. And these are some of the activities carried out all around the world and the response from the people. This is the group in Bogota, Marta's group. Another collection sample from Alina and Tanya in Ukraine. And Peru, transportation systems again. So these are the sites that the samples are collected from. And we had several articles on this one. So we are identifying new genomes, new species. So, and adding it to the open knowledge in the society, where we can learn a lot from these newly identified genomes. And we identified novel peptides and for potential health benefits. And also, we are keeping track of the AMR dynamics, antimicrobial resistance dynamics all around the world, and we can see some hotspots where there are serious threats. So we can map the world using this approach. These are the antimicrobial resistant tracks. If the color is getting red and bigger, that means there is more antimicrobial resistant genes transferred at these locations. So that means the organisms living in those environments are more resistant to antibiotics. So there is a serious threat at those locations. And we try to carry it out in Turkey. Even though I'm a member, I'm a bioinformatician, so I'm helping with the bioinformatics. We have Resistom in Turkey, unfortunately. I tried different routes to get permit to collect samples from the subway systems. And they thought that if the information leaked out to the newspapers, it would be creating bad publicity that we are not keeping our subway systems clean, which is the case all around the world, and not knowing is not solving the problem, but I couldn't convince them. So, and also because of the refugee issues, we have one publication out that Leishmania cases were eradicated from Turkey. It came back, and it's seen heavily in the refugee living areas. And one of the cases that we wanted to collect samples from the metro stops near the refugee living areas. And they said that these cases would create bad publicity against the refugees in the public. So that's why some of the officials said that we don't want any samples to be collected in those areas. But we are exposed to those things. And we are seeing new cases coming up. And they are resistant to known treatments. And it's a serious public threat. And it's an issue that comes in when you have millions of people coming into a country. They bring in their own metagenome and microbes, and it changes the profile of the country as well. And we don't look at these aspects of the problems at all. And this technology enables us to screen and prevent, in a way, such risks. So this is a presentation of the Metasub, and Gaston will talk about his experience in Uruguay and how he applied it. Thank you.